Okay, so on to the last problem. So question number 7. Here we are doing some Hamming and coding. And so we are receiving this message 11011000, and it says how many Hamming bits are included in this packet. So we could go with the fact that the Hamming bits are at powers of 2. So 2 to the 0, 2 to the 1, 2 to the squared, 2 to the third would give us 1, 2, 4, 8. And if we look, we've got 1, 2, 3, 4, 5, 6, 7. So given that 8 is not there, we don't have that 2 to the third, meaning that we could assume that these are the correct bits. But let's use the equation here just to be safe. So we need to have 2 to the n is greater than or equal to n plus m plus 1. And so given that we've got 7 bits, we've got some number of n plus m, which is less than 7. So we can say that this is 2 to the n is greater than 7 plus 1 is 8. And so then log 2 of 8 is going to be 3. So if we assume n is 3, then we've got 2 to the 3 equals 8 is greater than or equal to 3 plus m plus 1. And so that implies that m is equal to 4. And that's what we're seeing here. So we have the 3 Hamming bits that are included in this, and then we have the 4 data bits. So let's rewrite that just a little bit bigger. So 110, 1000, and our Hamming bits are going to be here, here, at the 1 position, 2 position, and the 4 position. So those are our Hamming bits. And then if we count 1, 2, 3, 4, 5, 6, 7, we have 1s at bit position 6 and 7. So if we're determining if a bit error occurred, we're going to take the Hamming bits, so h equals 100, and then we're going to take the binary values of any bits that are set to 1. So 6 and 7 are the two that are set here. So 7 in binary is 4 plus 2 plus 1. That's 4 plus 3, 7. 6 in binary is going to be 4 plus 2, not plus 1. And those are our only values that are set to 1s here. So we're going to XOR all of these together and see if it comes out to 0. If there are no errors, then this calculation will come out to 0. And we've sort of done it this way that the Hamming code is the value that should come out of this. So if we want to sort of see what happens if we had 7 as 111 and 6 as 110, our Hamming code should have been 100 or 001. So again, if it's an odd number of ones, that XOR is going to be a 1. If it's an even number, it's going to be a 0. So we should have had this Hamming code, but instead we have that. So that means there's an error. So let's see what that error bit is. Again, if we have an odd number of 1s in the column, then our result is a 1 for an XOR. If we have an even number of 1s in the column, then our result is a 0. So we get 101, and that indicates that bit 5, so 5-bit, was an error. And so we had a bit error at bit 5. Moving on to part C, we'd say what is the original message, not including the Hamming bits. So we should have received, because bit 5 was an error, we received 110, 1000. But what we should have gotten was 1, 1, and bit 5. So again, 7, 6, 5, 4, 3, 2, 1. So bit 5 here was the problem. That should have been a 1 instead, 1000. And that will give us this as our original, what we should have received over the transmission line, keeping in mind that these bits are still our Hamming bits. We're getting rid of those, and so the ones that are not the Hamming bits are the original message, which would be 1110. So 1110 is our original message, and we can double check, just since we have time here, if we redid this calculation that we did up here, and take that Hamming code of 100 with 7, 111, 6, 110, and 5, 101. If we repeat this calculation, well, now we've got an even number of 1s, so that's a 0, even number of 1s, and an even number of 1s. So no errors. So that's what we should have received, is this transmission with those Hamming bits, and that meant that we didn't have an error, hence that this is our original message. So that's it. Good luck on the final.